What's up, shipbuilders? Now, I just have to say, before we get started, I genuinely love the comments and debates about why the ship you built could destroy all challengers. It's why I make these videos. But I've also read plenty of forums, comments, and other claims that the SAL-6830s are the best engine in the game, and to even suggest otherwise is blasphemous. Well, I'm going to take that risk and say this. The SAL-6830s are not the best engines in the game. And to prove it, we're going to dive deep into stats, maybe do some controlled testing. But one thing before I jump in. I do have to confess, I was once a believer in these engines too, to the point where I actually put them on all of my ships. It certainly helps their mystique that they only unlock after completing a specific quest, which I'm not going to spoil for you, but you can easily find it online. Plus, a single SAL-6830 engine only consumes 2 reactor power, meaning you can put up to 6 of them on your ship, which is the highest amount of engines you're allowed in the game. Further, you multiply that 6 by their already very high maneuvering thrust, and you can see why just large numbers make people fall in love. But they also have the slowest top speed of any engine in the game. And when you fully equip 6 of them, they also have the second highest mass of any engine in the game, which negates so much of their high maneuvering thrust. So we see a shiny object locked behind a quest with large stat numbers, and we're in love. We have to have it. But I'm going to say what nobody else wants to say. I think your love has blinded you. And to fix that, I think we need to start from the beginning. Now, engines provide you primarily with 2 things. At least 2 things that the game allows you to see. Mobility and top speed. But to determine which engine is truly the best, we actually need to analyze a few more stats. Top speed, including boost speed, your maneuvering thrust, your engine thrust, and your mass. Now, when you think of any motorsport or racing event, there's speed in a straight line or around an oval, but that does you no good on a track where you have to deal with corners. Space combat requires all of the above: speed, acceleration, and maneuverability. And in Starfield, those statistics are determined by your engines, plus the overall mass of your ship. And the mass of your ship is significantly impacted by your choice of engines. So, we're going to start with speed. I'm sure you know by now that engines are organized into 3 classes: Class A, Class B, and Class C. Top speed is actually limited by your engine class. Class C engines are the slowest, with a statistical top speed in the shipbuilder before character or crew bonuses of 130. Class B are a bit faster, with a top speed of 140, and Class A are the fastest, with a top speed of 150. And there is one outlier, the White Dwarf 3015 engines. Technically, these are Class A engines, but for some reason, they have a top speed of 180. So, the spread between the slowest engines, Class C at 130, and the fastest, Class A at 150, is only 20 points, and yet the White Dwarf 3015s are an additional 30 points faster than all other Class A engines. However, this is where it begins to get a bit more complicated, and it's actually only going to get much more complicated as we dive deeper. You see, your ship's top speed will actually be determined by the slowest engine you place on your ship. That means if we take a ship like this one, with 4 White Dwarf 3015s, and let's say we replace 3 of those engines, with 1 Class A, 1 Class B, and 1 Class C, you will see our top speed decline with each successive class of engine. We start from 180 with the White Dwarfs, and we go down to 150 when we place a Class A engine. Then down to 140 when we place the Class B, and finally down to 130 when we place the Class C SAL-6830s. So, key point to remember is, your ship's top speed is determined by the slowest engine you place on your ship. But what about your ship's mass? I said mass is important. Does your overall mass impact your top speed? The answer might actually surprise you. Now, I have a side-by-side comparison of a lightweight combat ship that has 100 mobility. It's outfitted with 2 White Dwarf 3015 engines. Compare that with a heavy cargo ship on the right with 0 mobility that has a single White Dwarf 3015 engine. What you'll notice if you look closely at the speed of both ships is that both can reach a max top speed of 280, which is the theoretical max top speed in the game. It's 180 from the White Dwarf 3015s, plus a 20% boost from my character's engine system skill, and another 30% on top of that from having Sam Coe on our crew. This is regardless of whether or not we're using all 4 White Dwarf engines that were allowed, or fewer, even just a single engine in the case of the large cargo ship. So it turns out that your ship's mass does not actually impact your base cruising top speed. However, notice what happens when I engage each ship's engine boost. Here you'll notice a significant difference. First, the additional thrust provided by the boost lasts for the same amount of time, no matter the mass of your ship. In my case, again with an upgraded engine system skill, it's 8 seconds. But the lightweight ship reaches a significantly faster top boosted speed than the heavy freighter. So while our baseline top speed is not impacted by our mass, our boost speed does appear to be crippled once we start adding mass. So the question is, how much mass is too much when it comes to your boost speed? In case you're wondering, I did go down the path of calculating how much additional thrust your boost provides. And before I start trying to do math in front of you, we need to establish a few things. Number 1, math is hard. Number 2, I do not have a degree in physics. And 3, space is just different. We would expect things to behave a bit differently in reality in space, and I'm not going to pretend to be an expert in that. One thing we already know is that our ships clearly have a max top speed, and they're capped at that top speed given our engine choice, even though theoretically in space, as long as there's thrust being applied, we'd continue to accelerate. That's not how this game works. So, setting all that aside, I've done quite a bit of testing on this, and I believe I've found the game performs consistently enough that we can use some fairly simple calculations to figure out how mass impacts our boost speed, and we can rely on them to make some conclusions. So hopefully, or hopefully not, you remember Newton's second law, force equals mass times acceleration. But there's actually another formula for acceleration too, the change in velocity over time. Now, we already know our boost duration is 8 seconds. And we know our change in velocity. We simply take our final boosted speed and subtract our base cruising speed. So now we know our acceleration. In the other formula, force equals mass times acceleration, we know our mass. It's just our overall mass of our ship. So from all this info, we can calculate our boosted engine thrust and compare that to our baseline engine thrust. And the findings might surprise you. What I discovered was that the boosted engine thrust was not a consistent multiplier to your base engine thrust. In fact, it was wildly inconsistent. What I mean by that is it wasn't as easy as saying, when I hit the boost button, I'm getting 2 times the engine thrust. It didn't work like that. It wasn't until I started testing at the boundaries of very lightweight and very heavy ship builds, at those far ends, something interesting began to appear. The boosted thrust began to plateau, either around 100%, which would be 2x for very heavy ships, or 0% for very lightweight ships, which that finally made the light bulb go off. The way that boost speed works is effectively to lift the ceiling of your maximum top speed, allowing you to accelerate to a higher top speed, except that higher boosted top speed is also capped. So then I quickly did some additional easy math and discovered that your boost speed is actually capped, and it depends on your class. So it's capped at 4 times your base cruising speed for Class A ships, about 3.75 times your base speed for Class B, and 3.5 times for Class C. Now what this means is that not only is your boost speed actually penalized for choosing a Class C engine, but at some point for all engines, there's no additional boosted speed for you to attain. You'll simply reach that highest boosted speed a fraction of a second before your boost meter runs out. So what this effectively means is that if you were hoping to optimize your ship with the lowest mass possible in order to maximize your boost speed, that isn't possible. And actually, if you do the math, your boosted thrust is being nerfed or reduced in order to keep your boosted top speed down. But the inverse also appears to be true. The more mass you put on your ship, the more additional boosted thrust you seem to get from your engines, up to that nearly 2x or 100% additional thrust from your base. This really seems to be a balancing act by the game, since if they gave you a flat 100% increase in thrust across the board when you boosted on a really low mass ship, while simultaneously lifting that top speed ceiling, you'd accelerate so fast that you couldn't control your ship from a gameplay perspective. So the best you can hope for is 4 times your base speed with Class A, but that drops to 3.5 times for Class C. And then again, how do we know where mass comes into play with this? Well, based on my rough calculations, it appears that so long as your total engine thrust per mass ratio is around 40 to 45, you can attain your maximum boost speed multiplier for your engine class. Now, I don't know why this figure of 40 to 45 is the threshold, except perhaps that the engine with the worst thrust to mass ratio, the SAL-6830s, is also at 45. So this engine actually is in the same family as the SAL-6830s, and we should point out this is actually bad news for the SAL-6830s, as their individual thrust to mass ratio is actually only 55, because they have such a high mass along with their high thrust. That puts them actually as the 6th worst engine for this statistic in the entire game. And for comparison, the White Dwarf 3015s have a thrust per mass ratio of 215, which is the 2nd highest in the game. So for the SAL-6830s, having such a poor thrust per mass means that if you add just a little bit of mass to the ship that they're on, which of course you're going to, because why else would you use them, you're actually then really quickly negatively impacting your boost speed. All right, that was a lot. Let's recap top speed real quick. First, Class C engines are the slowest in the game, Class A are the fastest, except White Dwarf 3015s, which are even faster by a significant margin. Your ship's maximum top speed is determined by the slowest engine you place on your ship, and your ship's mass does not impact your base top speed, but it does impact your boost top speed. So to ensure a maximum boost speed, you need to aim for an engine thrust per mass ratio of around 45. I do need to take a moment and have a quick aside for the Amun-7 engines. Through my testing, I did notice that these engines, while their top speed is a little bit slower than the White Dwarf 3015s, they're only Class A engines, their boost speed is actually the highest in the game. They can reach a speed that's about 50 meters per second faster at the max of their boost speed than the White Dwarf 3015s. Now, I don't think that elevates them higher than the White Dwarf 3015s, simply because that max boost speed is just for the briefest fraction of a second, and otherwise they're slower than the White Dwarfs. But it was an interesting finding, and one that I really can't explain, other than the White Dwarf 3015s also seem to be unique in their own right. All right, let's go on to maneuvering thrust. So while top speed declines as you go up in class from A to C, maneuvering thrust, which positively impacts your mobility stat, actually increases as you go up in class. So in general, Class A engines have the lowest maneuvering thrust, while Class C engines have some of the highest values in maneuvering thrust. So it's pretty evident by now that your ship's mobility stat is primarily impacted by maneuvering thrust. But it's a bit more complicated, as again, your mass of your total ship plays into that statistic as well. The more mass your ship has, the lower its mobility. Now, mobility is something that's actually clearly displayed to us in the shipbuilder, and it appears that it's capped at a maximum value of 100 and a minimum value of 0. So no matter if you have extra maneuvering thrust on a lightweight ship, your mobility can only go so high. Similarly, it can only go so low once you're at 0. So you may as well add more cargo at that point because there's no additional penalty for additional mass. But is that actually true? Let's test it. So what we've got is a ship with 0 mobility, but it's only just at 0. You'll see if I remove just 1 point of mass, the game will display that my mobility is now greater than 0. So what we're going to do is compare that ship's mobility and rotation to a ship with the exact same engines, but a lot more mass, to just see if that floor of 0 is actually a true floor or not. And the first thing we're going to do is we're going to rotate and not use our thrusters. And you'll see it appears that they turn at about the same rate. I'm going to speed this up a little bit just because they turn so slow. But they do in fact turn at the same exact rate with or without using thrusters, which would say mobility truly does have a minimum value. Now, just to be sure, let's look at the opposite end and see if there's a true maximum ceiling. So similarly, we've got a ship with max mobility, but only just. If I add 1 more point of mass, you'll notice it starts to drop below a mobility of 100. And then for comparison, we'll take this exact same ship, but we'll switch out these White Dwarf 3015s for 6 SAL-6830s, which altogether provide much more maneuvering thrust than the White Dwarfs do. And so with all 6 of these SAL-6830s, we'll have mobility to spare, theoretically, above even the ceiling of 100. And so we'll see if this ship with more maneuvering thrust above that ceiling of 100 actually rotates faster or not. Now, as you would expect, each of these rotates quite a bit faster than the 0 mobility. And you can see we're doing this first without thrusters, but you'll also notice they rotate at the exact same speed, regardless of having much more maneuvering thrust or not, which seems to prove mobility is truly capped at both ends, at 0 and at 100. And while maybe that's disappointing, it actually makes our job a little bit easier, as we can now always add additional modules or cargo without fear of losing mobility until we see that mobility stat drop below 0. And actually, we can do a quick calculation to figure out the highest mass your ship can have and still have maximum mobility. If you take your total maneuvering thrust and divide that by about 12.4, now I think the actual factor is closer to 12.35, but 12.4 is close enough. The resulting number will tell you the mass above which you will begin to go below the maximum mobility of 100. So again, total maneuvering thrust divided by 12.4, that'll give you a number, and that mass number is what you want to stay below to have a mobility of 100. However, this actually isn't the end of our analysis on mobility, and that's because the terminology that this game uses is deceptive. The word mobility implies more than it actually means in practice. It implies the ability to change directions quickly. But what the mobility statistic displayed to you actually impacts, as we already saw, is just how quickly you can change the direction your ship is facing. Basically, how quickly you can rotate. But if you're still traveling in the same direction at the same velocity, the only difference is you're essentially now facing backwards, as if spinning while sliding on ice. You haven't actually changed directions at all, and your enemies haven't had to adjust to you either. your actual mobility in this scenario isn't very mobile at all. So what we're going to look at next, your engine thrust, is what impacts your ability to change your velocity, or your momentum, or maybe more accurately, your acceleration. It's also something the game doesn't show you at all. We already looked at how engine thrust impacts boost speed, but we also need to look at its impact on our base cruising speed as well. So to test engine thrust and its impact on flying was actually a bit of a challenge. That's because to truly test its impact, we have to keep all other factors unchanged. That means we need to compare how separate ships perform when their top speed is the same, their maneuvering thrust is the same, and their mass is the same, but their engine thrust is different. So to figure this out, I listed out all engines and their stats and identified engines within the same class, so their top speed was the same, and they had the same maneuvering thrust, but different engine thrust values. And what I hoped for was a significant difference in engine thrust, so the results would be more distinct. And then for each ship, I'll need to ensure their mass is exactly the same, as the mass of separate engines would likely be different, so I'll have to add or subtract a few different components to get mass to be equal. What I found was that the White Dwarf 2030 engines and the Ares DT10 engines were both Class A, both had the same maneuvering thrust, but their engine thrusts were different. The White Dwarf 2030s was over 50% higher than that of the Ares DT10 when a ship was equipped with the full amount of each engine allowed. So now we have our two test engines, and to adequately test this, we're going to look at two different versions of ships for each engine. So one with high mass and 0 mobility, and the other with low mass and 100 mobility. And we're going to look at how quickly each can reach their top speed, which will be the same for all of them. So what you'll notice is that there is actually a difference in the time it takes for each configuration to reach the same top speed. For the lightweight ships with 100 mobility, the difference is basically negligible. It's about a second, maybe a second and a half, which is measurable, but in actual gameplay it isn't that significant. For the heavier ships, however, it is pretty significant. About 7 seconds difference between the two engines. Now, we don't need to revisit all that math we did early in the video because our conclusion here is essentially the same. The game doesn't show you your total engine thrust per mass statistic, but it's clearly important, particularly for heavier ships. Now, on the other end of the spectrum, as your ship's mass is smaller and smaller, the benefit you gain in acceleration is actually negligible. So, time for one final recap. Regarding top speed, Class C engines have the slowest top speed in the game, Class A are the fastest, White Dwarf 3015s are faster still. Your ship's maximum top speed is determined by the slowest engine you place on your ship, and your ship's mass does not impact your base top speed, but it does impact your boost speed. To ensure maximum boost speed, aim for an engine thrust per mass ratio of around 45. Mobility, which is how quickly you rotate, is determined by your maneuvering thrust versus your total mass. The key factor here is 12.4. Specifically, maneuvering thrust per mass ratio of 12.4. If your mass goes above that ratio, your mobility starts to drop below 100. Finally, acceleration is a hidden stat, as your top speed isn't as valuable if it takes forever to reach it. Acceleration is primarily impacted by engine thrust versus your total mass. Generally, Class A engines have the best thrust-to-mass ratio per engine, but Class C engines provide the highest possible total thrust. So taken all together, what engine is the best? Now, I know what you're thinking. This is the part where I don't give you a firm answer. I say it depends, and you're kind of slightly angry you watch this much of the video, but no, I'm not going to do that to you. I think the answer is actually quite clear. Mass has a significant impact on your ship. Not just on your mobility statistic, which we learned is actually just your ability to rotate, but and especially on acceleration, which is not just how quickly you reach your top speed, but how quickly then you can actually change directions. So acceleration is just as important, if not more important, than that mobility stat we're so focused on. But the game doesn't tell you that. So knowing what we know now, that mass is such a significant component, we can actually quite easily consider each engine's thrust to mass ratios, as there are engines that are clearly better performers than the others. So what's immediately clear is if you want the best performing engines in terms of thrust per mass, which you can equate to acceleration, the White Dwarf series, along with a couple of Slayton engines, specifically the Class A SA-4330s and Class B SAE-5660s, are the best in the whole game. Also, considering the White Dwarf 3015s have the highest possible top speed, separates them from the rest even further. Now, I've also previously shared in another video that the max top speed of the White Dwarf 3015s, once you're fully leveled your character's engine system skill and put Samco on your crew for that additional speed bonus, gives these engines an unfair advantage in your ability to outfly, outboost, outmaneuver all other enemy ships. Looking at maneuvering thrust per mass, again, the Class A SA-4330s and Class B SAE-5660s, both Slayton engines, jump to the top of the list. What this would indicate is that, contrary to popular opinion, these Slayton siblings to the SAL-6830s actually perform better pound for pound than their heavier Class C brothers. To further support these engines, given the data we've gathered, we can actually calculate a couple of additional metrics that paint a pretty clear picture regarding which engines are the best. Now that we know about boost speed and acceleration being closely tied to our ship's mass, and specifically the threshold that once our total engine thrust is less than 45 times our ship's mass, our boost speed suffers, we can calculate the extra mass each engine provides above its own mass before we would exceed this threshold. And when we analyze this figure, we see a similar picture. The Class B SAE-5660s, Class A SA-4330s, and the White Dwarf 3015s are still near the top of our list. We can also do the same calculation for mobility and our maneuvering thrust. Now that we know that mobility begins to decline once our ship's maneuvering thrust is less than 12.4 times our own mass, we can actually calculate the additional extra mass each engine provides above its own mass before we would exceed this threshold. And as expected, we still see the best Class B engine is the SAE-5660s, and the best Class A engine is the SA-4330s. But notice, finally, we see the SAL-6830s rise to the top of something. And are we surprised? I think we all expected them to be the best at carrying large amounts of cargo while maintaining mobility. Except we now know that the mobility metric is a bit deceiving. And if you actually look at these engines' additional engine thrust mass metric, it's very low. Only 420 additional mass before you start losing that boost thrust, which actually places them near the bottom 10 of all engines in the game. So are they actually as mobile as we assumed all this time? So look, there is a place for the SAL-6830s, where they do perform better than other engines. They do actually have their own niche in the game, and that is if you're going to build a massive cargo hauler and you want as much cargo as possible, while still having a mobility stat that is decent or even up to the max 100 presented in the shipbuilder screen, so that you can rotate quickly to at least watch what you cannot outmaneuver, the SAL-6830s, even with their own high mass, do provide the most extra mass to allocate across your ship before reducing that mobility statistic. I concede that point. However, I think what we've learned is that mobility doesn't equate to mobility. We need acceleration. So yeah, you can rotate quickly, but you're not actually changing directions all that quickly. And their slow top speed doesn't give them any points in this debate either. So yeah, there's certainly a place for these engines on large, heavy cargo ships. But for me, if given the choice, I'd choose to drive a sports car rather than a city bus any day. Now, as I said at the very beginning, I genuinely love this debate. It's truly up to you how you play the game, and obviously how an engine looks and fits into your overall build is actually the most important thing. Whether you prioritize cargo or not is also your decision. And regardless, whatever your choice of ship build, I hope this in-depth analysis gives you the information you need to make your ship the best it can be. Until next time, keep building.